should be okay. If I add and subtract fractions, you have to have a common denominator. Yes. Multiply, divide, no. Add and subtract, yes. So maybe, let me just make up like a little problem at the top. So let's say, like if I did, I don't know, let's say I did 2/5 plus 1/5. Okay, they have a common denominator. If you add those together, does that become 3/10, or what does that become if I add 2/5 and 1/5? Do you guys remember? Is it 2/10 or it's 3/5? Okay, I just wanted to make sure. Now, all these questions on the front, they all have a common denominator. You don't change the denominator. So 2/5 plus 1/5 would end up being 3/5. So the denominator should stay the same. You only add or subtract. This is a little example with adding, but you only add what's on the top. You keep the denominator the same. So just to remind you of that. So all these ones on the front, like this one says 8/3a plus 1/3a. We're in good shape. We already have a common denominator. All you're going to do is add the numbers, if you can, on the top. So this would just be 9/3a. Okay, can I simplify that at all? 9/3a. Yeah. Okay, yeah, just 9/3, right, would be 3. So this would simplify to just be plain 3/a. You're totally, I don't have any adding or subtracting. It's just 9 and then 3 times a, so you can reduce the 9/3. Now, for your restriction, the only thing that would cause us a problem, we just don't want a to be 0, because that would cause us to divide by 0. But that's all you have to do. Okay, anybody have a question at the moment? All right, now the next one is subtraction, and these can be very tricky. So my denominator here for both of these is 4x minus 3. All right, so that's not going to change. All right, what I would always tell you to do, you have 5x minus 1 minus this other fraction, which is negative 7x plus 8, especially if it has more than one term, like this has 2 terms. You have to subtract both parts of that, so just be super careful to think about that, maybe like distributing a negative 1. So on this question, you'd have 5x minus 1, so it'd be minus a negative 7x, so that would actually turn into plus 7x. And then minus this 8 would be a minus 8. And then I'm just going to simplify that a little bit, just combine any like terms that you can. So you got a 5x and a 7x, so I'd have 12x. And then negative 1 and negative 8 would be negative 9. So that would be the top of the fraction. And I'd have that 4x minus 3 on the bottom. Okay, now before you write that as your answer, just think about, could I do any type of factoring? So like on the top or the bottom, like I don't have a quadratic or anything there, but do I have any greatest common factor in the top of that fraction or the bottom of that fraction that we could maybe take anything out? Like, do 12 and 9 have anything in common? 3. Okay, so if you can factor it, like the top of this, I can take a 3 out. Left over, that would be 4x minus 3. And that ends up actually matching the denominator. So on the top, I've got a product. I've got the greatest common factor, that 3 times 4x minus 3. So then this is similar to what we were doing the last couple of days. This actually just goes. So the answer to that question is 3. Now, the only thing that's in the denominator there is that 4x minus 3. So for your restriction, you just don't want the bottom to be equal to 0. In that case, if I set that equal to 0, I would add 3 and divide by 4. So 3/4 would be your problem number for the bottom of that fraction. These are not too bad to do, but just see if you can factor something maybe a little bit as you're going through the problem. Okay, so these all have common denominators. Let me just work with the top here real quick. I'm just going to subtract this. So I've got x squared plus 7x, top of the first fraction, and I'm going to subtract x squared, and then this is subtract negative 35. So minus a negative, that actually turns into a plus. The x squareds in that situation actually cancel each other out. So the top of the fraction would be 7x plus 35. Can I factor 7x plus 35 in any way. They're both divisible by 7 for sure. And then the bottom of that fraction, I'm going to see if I can factor that too. So on the top, you can, my pen is dying. On the top, you can pull out a 7. So we'd have x plus 5 left over. For the bottom, could you guys maybe think of two numbers, if you multiply them, you get negative 20, add them, you get positive 1? Yes, okay. So x minus 4, x plus 5, that's the factored form of the bottom of that. And then guess what? That x plus 5 actually matches the top. So all completely simplified here, this is going to be 7 over x minus 4. Now, the only stuff that's in the denominator was this x minus 4, x plus 5. So we would not want x to be positive 4 or negative 5, because if it plugged in for either of those x's on the bottom of that, we'd get 0, and that would be a problem. Okay, so just be real careful with the subtraction. You got to distribute the subtraction sign. Okay, so let me try this one. So the top of the next fraction, I got x squared minus 6x. Then I'm going to do minus x, and then minus a negative 12. Minus a negative would turn into a plus. So this is just the top of the fraction. So if I simplify that, I get x squared minus 7x plus 12. And the common denominator, which was already the same when we started the problem, was x squared minus x, and then minus 12. And then just ask yourself real quick, like we were doing the last couple of days, could I factor anything on the top or the bottom? So for the top of that fraction, could you think of two numbers? If you multiply them, you get positive 12, but if you add them, you get negative 7? Okay, so if I come back real quick here, if you subtract, so it'd be like minus x, and then you get minus a negative. You got to distribute the subtraction sign. So whenever you do minus a negative, it becomes a positive. That's a really good question. But that should be a 12. So can I multiply to get positive 12, add to get negative 7? Perfect. Okay, so x minus 4, x minus 3. Only way to get a positive number when you multiply and a negative number when you add, they both have to be negative. Okay, what about the bottom? Can you think of two numbers to multiply to get you negative 12, but add to get you negative 1? Not 6 and 2. It's got to be 4 and 3. Which one has to be negative? If I want a negative 1, the 4. There you go. So x minus 4, x plus 3. That'll multiply to get you negative 12. Negative 4 plus 3 will give you the negative 1. What ends up happening, the negative 4's match. So my answer ends up being x minus 3 over x plus 3. Nothing else cancels there. Those don't match. One's a plus and one's a minus, so they're totally different. And our restrictions, we would not want x to be positive 4 or negative 3. Okay, and I have one last question here. This one's just adding, so you really don't need to worry about distributing a negative if you're adding. What I'm going to do here, I have a common denominator. I am just going to combine the like terms on the top. So we don't have to distribute a negative. We're not subtracting here. So I just have x squared. 4x and 2x would give you 6x's. And then I have a negative 7. The bottom of that is x minus 1 for both. So we already had a common denominator. Can I factor the top at all? Think of numbers that would multiply to get you negative 7, but add to get you 6. It's got to be 7 and 1. Those are its only factors. Which one has to be positive? So I got to use 7 and 1. Does the 7 have to be positive, or the 1 have to be positive to add up to 6? The 7, right? Okay, so x plus 7, x minus 1, and then, magically, that cancels the denominator there. So we're left with no fraction anymore. This is just x plus 7. But even though it canceled out, I had that x minus 1 in the denominator, so we have to use that as a restriction even if we cross it out. So positive 1, if I plug that in for x and x minus 1, that would make the denominator 0. Does anybody have any question? Okay, now all of these on the front had a common denominator. On the back, we're going to work with a couple problems that don't. So before we do that, I just have a couple just with numbers to practice this. So they do not have a common denominator, but I have to have a common denominator if I want to add or subtract fractions. So if I gave you 1/2 plus 1/3, how would you change that up so you could add those two fractions together if you needed a common denominator? Do you guys remember how to do this? Like, what would you do to the first fraction? Multiply. Good. Okay. So what are you going to make your common denominator? 6. Okay. 6, 2, and 3 both go into 6. All right. So I'm going to multiply top and bottom by 3, which is really multiplying by 1, right? 3 over 3 is equal to 1. So we're not changing the value of the expression. We're just manipulating it so we can put stuff together. Okay. What would you multiply the top and bottom of 1/3 by? 2. Okay. So this would become 3 over 6, which that's a half, right? It's like we're unreducing it, basically, to help ourselves do this problem. And this one would be 2/6. That would reduce back to 1/3, but we want it to have a common denominator so we can add them. And then, remember, you keep the denominator the same. That's going to stay 6, and you just go ahead and add across the top. 3 plus 2 would give you 5. So it'd be 5, 6. What would you use in the second example? I've got 4/5 minus 3/10. What would you use as a common denominator for 5 and 10? Oh my goodness. You guys remember doing this? Adding and subtracting fractions? What would be a common denominator between 5 and 10? 10, right? So like this one, I had to multiply both of the fractions to get a common denominator. Here, if you can, try to just multiply 1 if that's possible. So if I just multiply the top and bottom here by 2, that's really multiplying by 1. That'll give me a 10, so this will be 8/10 minus 3/10. I already have a 10 as a common denominator, so sometimes you might have to multiply one fraction, sometimes you might have to multiply both. It's just going to depend on the question. And then just go ahead and subtract. So 8 minus 3 is 5, 10ths on the bottom, and then I can actually reduce that. That's going to be 1/2. Is anybody having a question? Okay. Now, this is a little bit weirder with the variables. Now, remember what we did here when we created a common denominator. We multiplied by something on the top and the bottom. You can't just add things into the top and bottom, which is kind of weird with these. Okay, so I have 3 over x plus 9, and I have 3 over x. You can't just like add a 9 to the top and the bottom of this. It doesn't work like that. It has to be multiplication by 1. So these can be kind of weird. So this first fraction, I'm going to need another x. So I'm going to multiply the top and bottom by x. And we're just going to leave this in factored form. Okay, we're just going to do this in factored form. This fraction, I'm going to need an x plus 9. To make these match. Again, you can't just add something or subtract something. It has to be with multiplication. So if they don't match, you're just going to multiply by what was in the denominator of the other fraction. Okay, here's what I'm going to do. I am going to simplify the top. So the top of this first fraction would be 3x. Go ahead, please, 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 just leave the bottom in factored form. So our common denominator here is going to be x times x plus 9. Okay, now on this second fraction, I'm going to have 3 times this x plus 9. So I'm going to go ahead and distribute that. That's going to be 3x plus 27. And on the bottom, I'm going to go ahead and leave it in factored form. So that'll be x times x plus 9. That's going to be our common denominator. Okay, now the reason I'm leaving that in factored form, we're going to simplify the top, and then we'll just see. And I don't know, but we'll see if anything cancels out here. So on the top, we're going to keep our denominator the same. The top, you're just going to combine like terms. We're just adding. So 3x and 3x, that'll give you 6x's. And then the 27, can't add that because that's not a like term. Before you write that as your answer, we already have the bottom factor. Can I factor or like do 6x and 27? Do those have anything in common? They are both divisible by 3. I'm just going to check real quick. So I could take a 3 out. This would be 2x plus 9. That is not in this problem going to end up canceling anything out, so that's okay. But I just want to check before I write that as my answer. And you can leave it in factored form. And for this one, we would not want x to be 0 or -9 because those two numbers would make our denominator 0. But just do a quick check before you write your answer. See if you could take a greatest common factor and maybe cross anything else out. But please just go ahead and leave the bottom in factored form, and that way it'll make it a little easier to work with. Okay, so we're going to ask ourselves, what are we missing? Again, you can't just like add or subtract something. It has to be multiplication. So if this says x minus 4 and this says x plus 2, this first fraction is going to need an x plus 2 on the top and bottom. The fraction next to it is going to need an x minus 4 on the top and bottom to make those denominators the same. Just go ahead, leave the bottom in factored form, but I am going to simplify the top. So on this one, if I got x plus 2, I'm just going to distribute a 2 to that. So it would be 2x plus 4. Now, the bottom, it's going to be that x plus 2, x minus 4. That's going to be our common denominator. Just leave that in factored form. We're going to add, on the other side, if I distribute the 3, we're going to get 3x minus 12. And just that same denominator, x plus 2, x minus 4. Doesn't matter the order that you write them in as long as they match up. So I've got an x plus 2 in one, x minus 4 in the other. Now, this one actually ends up being addition again. So I'm just going to combine like terms on the top real quick. So 2x and 3x would give you 5x. And 4 minus 12 would be what, -8? And then I've got the x plus 2, x minus 4 on the bottom. And 5x and 8, that doesn't have anything in common. So this is just going to be our answer. There's nothing I can factor on the top of that at all. So that's not going to simplify any farther. But we do have some restrictions. We don't want x to be -2, and we don't want x to be 4 positive. Those would both make our denominator 0. Does anybody have any questions? Okay. Now, these are a little trickier. I'm going to factor the bottom of this fraction real quick. So I have 4 over, and then I've got 5x plus 10. Would you guys be okay with me saying 5 and 10 are both divisible by 5, right? Okay, so this is really in factored form, that first fraction, 4 over 5 times x plus 2. You want it in factored form. It'll make it easier to do. Okay, now, the other fraction, I'm subtracting 5 over this 12x minus 24. Well, 12 and 24 both are divisible by 12. So I'm just going to pull that greatest common factor out in front to see if we can simplify this a little bit. If I do that, that gives me x plus 2. Okay, now, here's how this works. Do you guys see? I do have an x plus 2 in both of those, right? Okay, so I don't need to multiply by that. What you got to basically put what you're missing in the other fraction. So this one has a 5 in the denominator. This one does not. So I'm going to need to multiply here top and bottom by 5. This fraction has a 12. This one does not. So I need a 12 in the top and bottom here to make my denominators match exactly. Okay, now on the top, we're just going to do 4 times 12, which is 48. And I'm going to leave this in factored form on the bottom, but go ahead. I have a 5 out in front of the parentheses and a 12 here. I'm just going to do 5 times 12. 5 times 12 will give you 60. And don't reduce anything. Like I know 48 over 60 could be reduced, but don't do that. We want to wait until we actually subtract these and then see if we can simplify. Now, the other fraction, to make a match, it needed a 5 in the top and bottom. So the top of the second fraction is going to be 25. And it should have a matching denominator. I'm going to take the 12 and 5. That's going to give you 60. And we already had the x plus 2. Now, don't try to simplify anything like the 25 over 60. I know that simplifies. But what I actually want to do the subtraction. So the denominator, we're just going to go ahead and leave that in factored form. 60 times x plus 2. And we're just going to do 48 minus 25. So what would that be, 23? Okay, now at this point, if you want, if you could, if 23 and 60, if that reduced, you could do that, but it doesn't here. So this is just going to be my answer. So you only need to introduce what you don't have to create a common denominator. So it doesn't necessarily have to be an expression. It might be a number. So like this one, I had to multiply the first one by 12 over 12, the second one by 5 over 5. There were no x's involved. So it just depends on the question. But I still don't want my denominator to be 0. So I don't want x to be negative 2 for that problem. Okay. And now I have one more. This one's probably a little bit tricky. So we'll try and if you have something in the bottom or the top that you could factor, try to factor it. So the bottom of that first fraction, I'm going to add these together. I've got 2x over x squared minus 9. This guy in the bottom is the difference of squares. So multiply to get negative 9, add up to 0. It's just a square root. So it's x plus 3, x minus 3. That's called a difference of squares. X squared is a perfect square. 9 is a perfect square. That's your factored form. Okay, now the other fraction, I got a 5 on the top, and I'm going to try and factor the bottom. So I got to multiply there to get negative 6 and add to get 1. So if I've got x squared plus x minus 6, can you think of two numbers you'd multiply them to get negative 6? Same two numbers, you'd add them, it would give you 1. That gives me 9. So if I want to multiply to get 6, okay, 3, 2. Okay, there we go. All right, let's see, plus 2. So it's got to be x plus 3, x minus 2. 3 times negative 2 gives you the negative 6. 3 plus a negative 2 will give you the 1. Okay, now, we're not multiplying here. This is an addition problem, so I got to make these denominators match. Okay, if you guys see this, I already have an x plus 3 in both of them, so that's good. So what I'm missing, I have an x minus 3 here. I don't have that over here. So to create a common denominator, I need an x minus 3 in the top and bottom of that second fraction. The other fraction has an x minus 2. This one doesn't have an x minus 2. So I'm going to need an x minus 2 top and bottom here. And just you're not going to FOIL that out. We're just going to leave the bottom in factored form. Don't worry about that. So I am going to distribute and see if I can simplify just a little bit anything I've got here. So 2x times x is going to give me 2x squared, and then 2x times negative 2 is going to give me negative 4x. And I'm just adding this, so I don't need to worry about distributing a subtraction sign or anything. But 5 times this x minus 3, so 5 times x will give you 5x. 5 times negative 3 give you negative 15. And all simplified together, I got 2x squared plus x minus 15. And then just go ahead and write the bottom of this. So we had the x plus 3, and these can come in any order as long as you got all three of them. X plus 3, x minus 3, and x minus 2. I'm trying to think if I can factor the top of that real quick. If I can, let me see real quick here. This would be multiply, first and last would be multiply to get negative 30, add to get 1. We can do that with 6 and 5. Okay, sorry guys, I wrote too big here. Let me just do, I'm going to do my little Berry method here to the side. So the factored form of that, multiply to get negative 30, add to get 1. I'm going to use 5 and 6. Has to be a negative 5 and a positive 6. Those will multiply to get you negative 30, but add up to get you 1. This guy is not the real factor because those are both divisible by 2. Sorry, I did not leave enough space to do this. Okay, the top of this fraction is going to be 2x minus 5. That factor will actually be x plus 3, which is actually going to cancel one of the pieces of the denominator. So we've got the x plus 3, the x minus 3, and the x minus 2. So the x plus 3's can go. I should have given us a little bit more room for this problem. The top then would just be 2x minus 5, and then the bottom the x minus 3, x minus 2. I'm not sure if there's one x, I don't know. But we're multiplying it. You'd have to FOIL that out. So it'd be like x squared minus 2x minus 3x plus 6. So if we were adding them, then we could do that. But this one's multiplication, so you got to leave it as multiplication there. And you guys can just leave it in factored form. Nothing else is going to cancel out there. Okay.